Light is interesting, and so is its nature. Determining the nature of light was quite a question for everybody until this man right here, Sir Isaac Newton, put forth a theory called the corpuscular theory, which stated light is made up of corpuscles. The theory explained everything but diffraction of light. This led Christian Huygens to find an explanation for the nature of light. He stated that light can be thought as wavefronts originating from a source placed in an hypothetical medium called ether. The wavefronts are nothing but disturbances in ether stating the light is propagating. This was called Huygens' principle. Huygens' principle motivated Thomas Young to formulate an experiment that could prove Huygens' postulates. The setup was to let pass monochromatic coherent light through an opaque sheet with two closely placed slits. If light behaved as a wave, the two slits would act as two coherent sources. The wavefront that originated from each of these sources would interact with each other, forming a pattern. The part where two crests or troughs met forms an constructive interference, while the parts where counterparts met resulted in destructive interference. The observation was an interference pattern made up of alternate light and dark fringes. This was a clear indication light behaved as a wave. We also know light is made up of tiny packets of energy called photons. When experiment was repeated by firing photons one at a time, the unexpected happened. Photons, unaware about the position of other photons, split into two, changed into waves, and interact with themselves. This was the craziest result ever to be found. But it is not over yet. When the experiment was aided with particle detectors, something spooky happened. As soon as a particle was measured, it conveyed an instantaneous message to the other particle half, and they both did not change into wave. This was because the wave function had collapsed. This was signified by the loss of interference pattern. What does it tell us about the nature of light? Well, the simple experiment showed that photons exist in a superposition of two states, namely particulate and wave-like. This exciting ability of subatomic particles to exist in two states at the same time was named as the dual nature or duality of light. Well, a weird fact is that the duality can be seen even in subatomic particles, atoms, and some molecules. Finally, if I may quote Heisenberg, not only the universe is stranger than we think it is, but it is in fact stranger than we can think.